Okay. I'm going to go through some problems on page 125. People want to go through 57, 58? Okay, so 57. 57 says two positive proper fractions. So what they mean by proper is, like, look at these two fractions. Which one is proper? 3/8. So like this is an improper fraction, so it doesn't want you to use that kind. It wants you to use proper fractions where the numerator is smaller than the denominator. So it says two positive proper fractions are multiplied. Is the product less than or greater than 1? Explain. Now, what you could have done is you could have just tried this out. All right? And the easiest thing to do is to pick a proper fraction that is positive that has a numerator of 1. For example, half times a half. So remember, when you multiply, you go check for cross simplification. And can you do it? No. So we're going to multiply across the top, multiply across the bottom, and what do you get? Okay, you get 1/4. So then you have to ask yourself, is 1/4 less than or greater than 1? It's less than 1, right? So let's try it again. We can do 2/8 times 4/6. What can we do before we multiply? We can cross simplify. 4 and 8 share 4, so we're going to go divide by 4 and divide by 4. And then we can cross simplify these two, right? Divide by 2, divide by 2. Now you can multiply across the top. 1 times 1 is 1. Multiply across the bottom. 2 times 3 is 6. Okay, again, ask yourself, is this fraction less than or greater than 1? Less than. Okay, so if you did this a couple more times, you'd find that it's always going to be less than 1. The interesting thing about multiplying with fractions, let's talk about multiplying with whole numbers, like numbers that we're used to multiplying with. Like 3 times 2 is 6. 6 is bigger than what? If you did 2 times 3 equals 6, your product is 6. What do you notice about your factors in comparison to your product? Are they smaller? Okay, come back up here to this one. Half times a half is 1/4. How does your product compare with your factors? Think about the size of that fraction tile. So here's your fraction tile. This is a whole, right? A half would be this piece right here. So that's how big a half tile is. 1/4 would be a half of a half, which is this big. What do you notice about that factor? The factor half compared to your product 1/4. Is 1/4 smaller than a half? So normally when we multiply whole numbers, like down here, our product, our answer, will always be bigger. But when we multiply fractions, our answer is always going to be smaller. This is why it's like that. Let me show you. So let's do 2/3 times 1/8. Okay, so if you're going to model this, what you would do is draw a picture for 2/3. So I'm going to draw a box. How many total columns should I draw? 3. That's my denominator. Okay, there's my 3 columns. My numerator tells me how many should be shaded. Okay, so there's 1, there's 2. Now, in a multiplication problem, we can model my 1/8 on the same picture or that same box, but I'm going to do it in rows. So how many total rows should I draw? 1, 2, 3, 4, 5, 6, 7, 8. And then double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, how many of them should I color in? One of them. And I have to color in the whole 8, which is all the way like that. So when you look at this, how many have overlapping colors? Only 2 boxes. You see them right here? Here's one overlap. Here's another overlap, right? I have 2 overlapping boxes out of a total of how many boxes? Well, I have 8 rows, and I have 3 columns, so how many total boxes are in there? Good, so you can treat it like an array. 8 times 3 is 24. So you get the answer of 2/24. Right? Do you see how that works? Multiply across the top, multiply across the bottom. Does it match what we got for our drawing? So that's why when you multiply fractions, you actually get a smaller number, is because you're just looking at what overlaps. Can you have more overlapping than what you start with? No, that doesn't make sense, right? So you can only overlap what touches when you do this box where you go one fraction goes in columns and another fraction goes in rows. So if they ask you to do a model for a multiplication of fractions, this is how you do it. Does that make sense? Okay. All right, so that should answer 57. When you multiply two positive proper fractions, your product will always be smaller than 1, less than 1. And then you can explain it by giving several examples, and you can show a picture of a modeling of fractions. Okay? 58. Write 3 multiplication problems to show that the product of two fractions can be less than, equal to, or greater than 1. Now, does this one say that you cannot use improper fractions, or can you? You can use improper fractions. It just says to show 3 multiplication problems with 2 fractions. The problem up above on 57, you could not use improper fractions. On 58, you can. Okay, so if you're not sure where to start with this, you can just pick a couple fractions and multiply them and see what kind of answer you get. So let's just do, I know that 10 over 5 is what? Two? Okay, so let's just pick an improper fraction. I'm going to change the black. Times 1/8. So what we're doing is I picked a number that has 2 wholes, and then I picked a fraction that is smaller, like a 1/8 piece. Let's see what happens when we multiply this out. Let's cross simplify. 8 and 10 share 2. So I'm going to go 8 divided by 2 is 4, 5 divided by 2 is 10 divided by 2 is 5. Multiply across the top, multiply across the bottom, simplify, divide by 5, divide by 5, what do you get? Okay, so let's think about what this means. I had 2 wholes multiplied by a pretty small fraction, and what did I get? An answer that's still less than 1. So this is an improper fraction times a proper fraction. Let's see what happens if I keep my 10 over 5, and this time I multiply what's like a bigger fraction that is proper. Like it's not going to be over 1, but it's pretty close to 1. Let's try 3/4. Let's see what happens. Okay, 10 and 4 can be reduced. Divide by 2, divide by 2, multiply across the top, multiply across the bottom. 10 goes into 15 one time without going over. 10 times 1 is 10. What's left? 5 over 10, which can be reduced to 1.5. Now what kind of answer do we get? This one is, this top one was less than 1. This one is greater than 1. So let's look at our factors to see what this means. We had 2 wholes. We had 10 over 5, right? So the closer we brought that second factor, that 3/4, up to 1, because 3/4 is pretty close to 1. We're only a fourth away. What happens to our product? It gets bigger, right? So this would be an example of a problem where your product is greater than 1, and the top one is an example of your product being less than 1. How can we write a multiplication problem where we would get 1? We know if you get a whole, your numerator and denominator have to be the same number. Okay, so let's just pick any fraction. I would suggest using 1s, because any number times 1 is going to give you that number. If I pick like 1/16 times something, and I want to get what over what? If I want it to be 1. If my denominator, do I want it to be 16 over 16? Yeah. So what would this have to be? So if you look across the top, I'm going to go 1 times what is 16? 16 times what is 16? Okay, and that reduces to 1. This is equal to 1. Notice your factors here. Look at these factors right here. What do you notice? 1/16, 16 over 1. Are they just flipped? Yeah. So these are called reciprocals. The reciprocal of 1/16 is 16 over 1. The reciprocal of 1 over 8 is 8 over 1. So the reciprocal is a fancy word for just flipping your fraction, like switching your numerator and denominators places. We're going to need to know this for the next lesson on dividing with fractions. Any questions? Okay, I want to talk about dividing fractions and mixed numbers. So I just got done talking about reciprocals on that one problem where it was like 1/16 times 16 over 1 will give you 1, because you get 16 over 16. So those two fractions are reciprocals, or multiplicative inverses. Okay, so if I gave you the fraction 1/3, the inverse of 1/3 would be, yeah, just 3, right? 3 over 1 is 3. So that's the reciprocal of 1/3. You need to know this when you divide. It says dividing by a number is the same as multiplying by its reciprocal. Let me show you. 6, oh, I don't like red. Let's do black. 6 divided by 3 is what?
2.
Yeah, okay. So you know this. I'm going to show you why multiplying by the reciprocal gives you the same answer. So I'm going to go 6 times, what's the reciprocal of 3? 1 over 3. 1 over 3. What do I have to do with the 6 before I can multiply? Put it over 1. Cross simplify. Divide by 3, multiply across the top, across the bottom, and what do you get?
2.
The same thing. Okay?
How do you know which one you're supposed to put over or under the second?
This one?
Like the first one, do you always put the first one in there under one and then the second one?
Oh, which one do you take the reciprocal of? You always take the reciprocal of your divisor, the second number. So when you say 6 divided by 3, 3 is your divisor. So you have to take the reciprocal of that second number, the divisor. So you only reciprocal this. And so I say it out loud to myself. Like when I say, let me give you an example of a fraction, division problem. So this is the problem that the book gives it to me. You must rewrite it as a multiplication of the reciprocal. So I say it out loud to myself as I'm rewriting it. 2/3 times the reciprocal of. If you do that, then you'll get it right. Okay, so you say whatever your dividend is, whatever your first fraction is, you say it out loud, 2/3, and then we're changing dividing to times the reciprocal of. That's the one you flip. Okay? And then do we know how to multiply by fractions? Yeah, we just did it yesterday and the day before, right? So then we check for cross simplifying. Can we cross simplify?
No.
So we cannot, and they don't share any factors. So I'm going to multiply across the top, across the bottom. But what do we have to do?
Divide.
We need to simplify because I have an improper fraction. So you say, yep, how many times will 3 go into 10 without going over? 3. 3 times 3 is 9. I like to write what it is here so that you know what's left over. 1 is your new numerator, and your denominator stays the same as what this one was. 3 1/3 is your final answer. Let's try another one. 3/5 divided by 6. Now, I have a whole number for a divisor. 6, right? What I would do is, before you rewrite it, is I know that 6 is equivalent to 6 over 1. You need to write it as a fraction, in fraction form. Okay, now I need to rewrite the problem as 3/5 times the reciprocal of. Make sure you do that, say it out loud to yourself, and then you'll make sure that you do it correctly. A common mistake is people will do this, 3/5 times 6. And almost every time I see this happen, because this is 6 the reciprocal of 6 over 1? No, it's not. Almost every time I see people make this mistake is because they forget to write it so they can see it. So make sure you put 6 over 1 before you take the reciprocal of it. Okay, this is not right. So then we rewrite it as 3/5 times the reciprocal 1 over 6. Go ahead and cross simplify. 3 and 6 share. 3, divide by 3, divide by 3. Multiply across the top, across the bottom. Do I need to simplify? No, final answer. All right, so that's what happens when you are dividing a fraction by a fraction or dividing a fraction by a whole number. Now let's look at what do you do if you divide a mixed number, 4 1/3, divided by another mixed number, 2 1/2. Okay, before we can do anything, you need to turn your mixed numbers into improper fractions. Okay, so remember to do that, you go denominator times your whole number. 4 times 3 is 12, plus whatever's in the numerator. Good, so you multiply here, you add here. So 12 plus 1 is 13. Keep your denominator. Okay, now, this is what I'm going to do. I'm going to rewrite this one as an improper fraction over to the side so I can see it before I take the reciprocal of it. So I'm going to go 2 times 2 is 4, plus 1 is, keep your denominator, 2. Okay, do you see how you can see it now? Now I can rewrite it as a multiplication problem beneath it. 13/3 times the reciprocal of. Make sure that you do not flip your dividend. Got it? That's another mistake I see people do. They want to flip that first number. Don't do it. Keep it as 13 over 3. All right, can you cross simplify 13 and 5? No. Can you cross simplify 2 and 3? No. Multiply across the top. 13 times 2 is 26. 3 times 5 is 15. I need to simplify because I have an improper fraction. How many times will 15 go into 26 without going over? Only one time. 15 times 1 is 15. 26 minus 15 is going to be 11. Keep your denominator. Okay, can you simplify any more? Nope, your final answer is 1 and 11/15. Okay, so it's the same thing, you just have one extra step here where you have to change your mixed numbers into improper fractions. Make sure you do this so you can see it before you flip it. All right? Let's do another one. 5/6 divided by 7 and a 7th. Okay, do you see how my divisor has a mixed number? Let's change it into an improper fraction off to the right so I can see it before I flip it. 7 times 7 is 49 plus 1, 50 over, keep your denominator. All right, now I can rewrite it as a multiplication problem. Keep this alone, leave it alone. 5/6 times the reciprocal of, can I cross simplify? Yeah. Sure, right here. 5 and 50 share 5. 5 divided by 5 is 1. 50 divided by 5 is 10. Now you can multiply across the top, across the bottom. 10 times 6. Can you simplify? No. 7 is prime. 7 will not go into 60. It is simplified. Any questions? Okay. 4 and 4/5 divided by 6/7. All right, what do we need to do before we can rewrite it as a multiplication problem? Maria, what am I going to do? Good. 4 times 5 is 20, plus 4 is 24. Keep your denominator. Remember, do not flip this one. This is your dividend. Times the reciprocal of. What can I do now? Simplify. Cross simplify. 6 and 24 share 6. So I'm going to go 6 divided by 6 is 1. 24 divided by 6 is 4. 4 times 7 is 28. 5 times 1 is 5. So you treat this as 28 divided by 5. So how many times will 5 go into 28 without going over? 5. 5 times 5 is 25. What's left over? 3. Keep your denominator, 3/5.
Wait, so like what happens when you have like a whole bunch of like the numbers? Like on like this one.
Okay, let's look at the word problem on the example 3. It says, use the bar graph to determine how many times longer a $100 bill is expected to stay in circulation than a $1 bill. Okay, so what do you ask to find on that? What do you ask to find on that problem?
How many times longer a $100 bill is expected to stay in circulation with a $1 bill?
Okay, so I am comparing the amount of time a $100 bill stays in circulation and the amount of time a $1 bill stays into circulation. Looking at the graph, you can see that which one stays in circulation the shortest amount of time. $1 bill. Why do you think $1 bills get taken out of circulation before $100 bills do? You use them way more. Like, I'm guessing some of you might have a dollar bill in your pocket. Do any of you have a $100 bill in your pocket?
Yes.
No, I don't even have a $100 bill in my pocket. So they don't get used quite as often as a $1 bill. Okay, so what information do we need?
Well, my mom had $100 bill one time in her pocket. Like we just like went to Missoula. She like checked her phone. She's like.
Okay, what information do we need? Look at the bar graph. How long does a $100 bill stay in circulation?
9 years.
9 years. A $1 bill stays in circulation approximately 1.5 years. Okay, so when I want to find out how many times larger one number is than the other, can I just divide them? Yep. I'm going to go 9 divided by 1.5 to see how many times larger 9 is than 1.5. What do I need to do to 9?
You put it over 1.
Put it over 1. What do I need to do to 1.5? Turn it into an improper fraction. 2 times 1 is 2. Plus 1 is 3. Keep your denominator. Now I need to rewrite it as a multiplication problem. 9 over 1 times the reciprocal of.
Wait, how do you say reciprocal?
Reciprocal. It's spelled like this. Reciprocal. Reciprocal. Reciprocal?
Yeah, reciprocal.
A lot of times you hear people say it like that because they say it quickly and it kind of like all the letters blend together. Okay, back to this problem. Can we cross simplify?
Yes, 9 and 3.
They share what factor? 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Multiply across the top. 3 times 2. And multiply across the bottom. 1 times 1. Simplify. So how much larger is 9 than 1.5? And then you would say a $100 bill stays in circulation 6 times longer than a $1 bill. Does that everyone understand that? Okay, let's do a couple of these order of operation rules. I want to do one with an exponent on it. I also want to do 40 would be a good one. Okay, let's do 40 first. Okay, we have 3/4 plus 3/20. What's next? Divided by what? 2/5. Times 7/8. Minus 1. What should we do with the 1? Well, just leave it. We'll leave it for right now. Okay, let's look at Pemdas. We could put it over 1, but let's wait. We might not have to do that.
We have to do most
Okay, so let's run through Pemdas first. Do we have parentheses?
No.
No. Do we have exponents?
No.
No. Do we have multiplying or dividing left to right? Which one comes first?
320 divided by 2.
Okay, I'm going to put those in parentheses so I know that that's what I'm going to do first, because what do you have to do with the division problem? You need to rewrite it as 3/20 times the reciprocal of. Cross simplify. 5 is the common factor, so divide 5 out, and we get multiply across the top. Okay, so now we need to rewrite it with everything we have not used. 3/4 plus 3/8 is what we solve for, times 7/8 minus 1. Go back up and do PEMDAS again. What's next?
Multiplication.
Okay, there's no parentheses, there's no exponents. We do have multiplying. I'm going to put a parentheses around those. That's what I have to do. Am I doing a reciprocal for this problem?
No.
No, because it's already in a multiplication problem. So I'm going to, can I cross simplify? No.
Yeah.
Multiply across the top.
21 over 64.
Okay, write everything down that you have not used. Okay. Now, all that's left is adding and subtracting. Do whichever one comes first. Okay, we know, use your ISN. If you're adding or subtracting, what format do you have to use? You have to use column format. So let's do it over here. 3/4 plus 21 over 64. You have to do what? Common denominator. Will 4 go into 64? Yeah, it will. Let's try it. 64 divided by 4. 4 goes into 6 once. 2, bring down. Good, 16. So I'm going to go 4 times 16 gives me 64. Therefore, I need to go 3 times 16 is 18 plus 30. I used the break apart strategy. 16 is 10 and 6. So I went 10 times 3 is 30. 6 times 3 is 18. 18 and 30 is 48. Okay, so you're using this guy right here. We're adding. We now have a common denominator, 64. Add your numerators. 48 plus 21 is 69. Okay. 64 goes in one time. What's left over? 5 64ths. This is handy because when we come over here and go 1 and 5 64ths minus 1.
It's 5 64.
Good. The 1, you can just get rid of your 1s. And you just have the fraction left over. 5 64ths. Bam. Okay, let's do 41. There's an exponent. Okay, let me go back. You will notice that all the work I had on that last problem, right? So you have to have that much work when you do the problem. There's no way that your brain can hold on to all those numbers. Okay? All right, next one. Half squared. What's next?
Which number are we on?
Plus a third.
Divided by 1/6 minus 1/4.
Is that it?
Yeah.
Okay, PEMDAS.
Exponent or parentheses.
Okay, so if you look at your parentheses, is there anything to do in the parentheses, or are they just putting it as half? Okay, so exponents. So we know that half squared is the same thing as saying a half times a half is 1/4. Copy everything down. 1/3 divided by 1/6 minus 1/4. No parentheses, no exponents. Multiplying and dividing. There's only one division problem right here. We need to rewrite it as 1/3 times the reciprocal of. Cross simplify. 1 and 2. Multiply across the top. Multiply across the bottom. What do you get? 2. Rewrite your problem as 1/4 plus, what do we get? 2 minus 1/4. Okay. 1/4 plus 2 is 2 and 1/4. Got it?
Oh, this is
2 and 1/4 minus 1/4 is 2. Bam. Okay? All right, now listen. You can go ahead and start on your assignment. Now, I'm not going to be here tomorrow, so you might want to start on some of your industrial arts questions. Okay?